get that going. Okay, so we'll start with question 8.
Okay.
Which says patient is ordered dopamine infusion to begin at 5 micrograms per kilogram per minute, with the patient weighing 70 kilograms. Dopamine available is 400 milligrams per 250 ml. At what rate should the nurse begin the infusion? So the we talk about infusion rates. Typically what we want to know is milliliters per hour. And so there's a lot of, and I apologize, the camera keeps fluctuating. So
You're okay.
There's a number, that doesn't really tell us what we want the infusion to be in. So my guess is that we want this to be in milliliters per hour. Okay. And okay. I know you have a key to this. And so that should be, I'll just double check. The key for number 8 is milliliters per hour. All right. So let's start off with some of the things. So we want milliliters per hour. And so if you ever get stuck, always start with the milliliters part of the question. So we know we have a solution of 250 milliliters, and then within that is 400 milligrams of the dopamine. Okay. So I'm writing this out on purpose this way because this will actually be one of the steps that we need to do in a moment. The other thing is we need to account for the patient's weight. And we know that the patient weighs 70 kilograms, and we have the weight-based medication says 5 micrograms kilogram minute. Okay. All right. So this, I'm going to just go ahead and do this first. That way I can account for the patient's weight. Gives me 350 micrograms per minute. Now, there's a couple things. This question has a lot of conversions involved with it. So we have to go from micrograms to milligrams. We have to go from minutes to hours, and then we have to account for the patient's weight. So things to keep in mind. Now, the reason I say that we need to convert micrograms to milligrams is because we have available 400 milligrams, but what's ordered is the 350 milligrams. Okay. Mm-hmm. So I need to account for that. And so what I can do is I can just go ahead and make that conversion now. So what I usually do is I just move my decimal point over. So this would be 0.35 milligrams, and that's still per minute. So that hasn't changed. Do you need me to show the math of going from micrograms to milligrams, or are you okay?
You're just dividing it by 1,000.
Divided by 1,000. You got it. Perfect. All right. So now what I'm going to do is I'm going to use this to basically get rid of the milligrams. And it's still per minute. So we're going to have to do something with that per minute in just a minute. But I want this to be in milliliters per hour. But this is step 1 of everything. So what I'm going to do is I'm going to take that 250. And of course, I closed out of my calculator. All right. I'm going to take the 250 times 0.35. And then I'm going to divide by 400. And I'm going to get some really small number, this 0.21875. So I'm just going to write that all out. 0.21875. And that would be milliliters per minute. Okay, because we got rid of milligrams, and then we have milliliters per minute. So I don't want milliliters per minute. I want milliliters per hour. So I need to do one more conversion, which is helpful because we're going to make this number bigger by doing that. So I'm going to take that number I got from the previous steps, multiply by 60, and then I get 13.125 milliliters per hour. And then the key is actually wrong on this. You would actually round this. You would want to round this answer to 13.1 milliliters per hour.
Okay.
So it's a multi-step multi-conversion type of question just to drive you nuts. So I
Okay.
hope the mission was accomplished. Did
Yes.
were you getting stuck on any part of this, or do you just want to make sure you were answering it the right way?
Yeah, because I was looking at Sarah online, the YouTube RN,
Oh yeah,
and
yeah.
when
Okay.
I would do her conversion, it wouldn't come out to the answer key.
Okay.
So it came out the same numbers, but the decimal wasn't in the same place.
Okay. What answer were you getting when you followed her method?
It was 131.25.
Oh, okay. That's interesting. There must have been there may have been a number conversion that kind of changed the answer. Meaning like if you had made this 3.5, like if there was a mistake by 10, then that would make this number bigger by a power of 10. So that could have happened in the conversion. I don't know her system well enough to see what you did or plugged in.
Okay.
But if you have did you write it out?
Yeah.
You can if you want to take like a picture of it and email it to me, I can tell you where the mistake is. Or if you want to, you have a way to do that on Zoom, you can certainly share it on Zoom as well.
Okay.
But if you want to just email me the picture, then I can give you feedback on why it came out wrong using an alternative method. I have a feeling that just something's off by 10, and it's usually something simple. And so, but I don't know unless I see it, if that makes sense. Yeah. All right. So let me move on to the next question, 11.
Okay. This one, the reason why I was hung up on this one is how it says your patient has congestive heart failure and it's ordered formazepamide 200 milligrams IV daily. The available dose is formazepamide 100 milligrams IV. We don't use the 100 milligrams IV in this.
Correct.
Is that correct? Okay,
Correct.
that's the reason. Why is it that we don't use that? Like I was able to get the right answer once I like kept messing with it to get it. I just wanted to know why we don't actually use the 100 milligrams.
Okay. So two like, I don't know if you want to call them secrets. So the order is 200 milligrams, right? So we need to use that. Okay. Then we have basically two available ways the medication can be administered. It says that the medication is available in an IV of 100 milligrams. Okay. So 100 milligrams of furosemide is in the IV. And then the label also tells us that the dosage strength is the 30 milligrams per milliliter. So basically this could be both on the same package, same label. Okay.
Okay.
The difference is like basically every milliliter is 30 milligrams. So if this were like, let's say this IV bag was let's say it was a 30 milliliter bag. I'm doing the math wrong on that. You can reverse engineer this to see how many milliliters this is in the whole bag, but we don't need to know that. And if we have the concentration, the other thing is when it asks how many milliliters, that's how you know to use this, because I can't calculate milliliters from that, because that would just be, it would just be 2 milligrams, or it would just be 2, but 2 of what? So that's why you take the 200 divided by 30, and that's where you get your answer.
Okay.
Yeah. So give me one sec. I just want to see 1 second. Just trying to work something out here and just to see. That's okay. I'm not going to try and figure this out. But essentially, yeah, your label is telling you two things. It's telling you how much total is in, but then how it's administered. Kind of like Tylenol, there's 500, whatever tablets in there, but each tablet has, is 375 milligrams per tablet. And so it's just, this is the total, this is the strength.
Okay.
Yeah. But yeah, you're fine. You're not alone in that, Tabitha, because a lot of people get hung up on, and that's the reason why when these questions were made, it was, like I said, to kind of make you think a little bit harder through the question, and then try and get you to kind of navigate through kind of the extra information that you really don't need in order to solve it. So.
Okay.
That
makes sense then.
Okay. All right. 16.
Yes.
Okay. So 16 is, okay. So 16 is another one that has extra information that you don't need.
Mm-hmm.
When we're calculating drop rate, so I think we're good with 11, so we don't need to do that. All right. When we're calculating drop rate, I need a couple pieces of information. I need the flow rate.
Mm-hmm.
I need the drop factor. And those two pieces of information will give me the drop rate. The flow rate is always going to be in milliliters per hour, but sometimes it will be in milliliters per minute. Drop factor is always drops per milliliter, and then drop rate is always drops per minute. So when it tells you that we have an IV of 500 milliliters, and then it's infusing at 120 milliliters per hour, I don't care about how much is there. I just care about the rate. So I always say it's kind of like, is it a Maserati or is it a minivan? It doesn't matter. We're going to be going the same speed. Okay. So it doesn't really matter. So you might prefer one or the other depending on where you are in life. But so it says 120 milliliters per hour. And I'm going to jump a step here. Just go ahead and convert hours to minutes. So 120 milliliters, 60 minutes. Just that way, it's one less thing you have to worry about at the end. So 1 hour equals 60 minutes. And then multiply by the 15, the drop factor. And then you get 30 drops per minute. Okay. Were you trying to incorporate the 500 when you were doing this?
Yes. Yes. And I was trying to figure out what I was doing wrong. And I'm like, this isn't coming out right. It's not coming out right. And I kept trying to play with it to try to figure out what I was doing wrong. That makes sense now. We don't need the 500. That's just the total.
Yep. You don't, and again, it's that extra piece of information that, they decided to add to some of these questions for your 4th semester test. The way the other way that this might like kind of, be written would be like, let's say you have 500 milliliters of the D5W to infuse over 3 hours, then your flow rate would be 500 over 3. But because it tells you the flow rate, you just use what they tell you to use.
Okay.
Does that make sense?
Yeah.
Okay.
If it says the flow rate, use that. Don't worry about nothing else.
You got it. Yeah. Don't try and add extra information. And then the same thing applies from the previous question. The reason you choose what you choose is because we're going from milliliters per hour to drops per minute. So you always want to use whatever thing has the time element, the per hour, which is the 120. So,
okay.
You're asking all the right questions, by the way. So this is exactly what you expect to see. So, all right. Now I'm assuming you did the heparin protocol last semester. Do you feel okay with them?
I don't feel too bad. It's just remembering why we're using what we're using. Like I have all my old notes from our previous sessions that we've had with you. And I was just like, okay, well, why did we use that? It's remembering why we're using what we're using. Because I do know that we're only really worried about 1, 2, like the answers for 1, 2, and 10 and 12.
Mm-hmm.
But it's just remembering why we're not worried about nothing else.
Okay. So let me, I'll rehash that. Give me 1 second. I gotta find
Okay.
another pen. Okay, hold on 1 second. I'll be right back.
Okay.
Okay. So when we're looking at, so the problem with this, oh wait, you know what? I have another version of this that's printed off a little bit easier. Let's see. So when we're looking at the heparin protocol, the thing that I've kind of squiggled on here would be like,
Okay.
what would be considered the protocol if you were to like just do a Google search to find a heparin protocol. Okay. And so, come on, camera, stop doing that. All right. And so you're right. You would, the things that will be given to you is the patient's weight, usually in pounds, you convert it to kilograms. And then as far as what you need to know in the protocol is definitely step 2 and step 10, because step 10 tells you what to do with the patient, bolus with 80 units per kilogram, and then start a drip rate at 18 units per kilogram. Step 2 tells you how to convert the units per hour to milliliters per hour, or to convert the bolus strength from units to milliliters. So we need that information. And then the boxed section tells us what to do after the patient has been under observation for 6 hours. Then we reassess their APTT and we see what to do with that information. So what I did with the 220, 230 class is I gave them basically a whole new question, and that's what I'm going to do with you. And we'll just kind of work through what that looks like, since you're already familiar with this and just kind of just need to rehash like what it is that you use, when you use it, and why. And so the best way we can do that is just by going through, and then I'll give you a new one. That way, you know, you're not relying on, oh, I remember doing this and this is what that answer was. This should be helpful and new. So what I'm going to do is we're going to create a new patient and a new patient weight. Now, sometimes the rounding on these don't work out so well, but it will still be fine. So what I would say is that when you're rounding from the pounds to kilograms initially, it's okay to round to the nearest 10th after you do that initial rounding. So don't feel like you're stuck and you can't do that. You're allowed to do that. But on the actual test, you probably won't need to worry about rounding so much. So.
Okay.
All right. So let's just say we have a patient that weighs, I don't know, let's just say 215 pounds.
Okay.
Okay. So we need to convert that to kilograms. We're going to divide by 2.2, and then 215 divided by 2.2 will give me 97.727272. So I'm just going to write 97.7272, and that's repeating. And we're going to go ahead and just round that to 97.7 kilograms.
Okay.
So here's the new scenario. Patient weighing 215 pounds, already under a protocol. They do, after 6 hours, they're going to check their APTT, and the APTT is 28 seconds. Okay. So 28 seconds, we look at the APTT times, and the one that applies is going to be step 11.
Okay.
Step 11 tells us to rebolus the patient with 80 units per kilogram per hour. Then we're going to increase the rate by 4 units per kilogram per hour.
Okay.
Okay. So step 1, calculating, this is, to us, it's the new bolus strength, but it doesn't really matter. It's just part 1. So we take the patient's weight in kilograms, 97.7, and then we're going to do the new bolus, which was the 80 units per kilogram. And again, where did I get that from? Just in the protocol. Okay. It told me to do rebolus with 80 units per kilogram. If we were just starting out, we'd be doing a bolus with 80 units per kilogram.
Okay.
All right. So we're going to take that 97.7 multiply by 80. And we're going to get 7,816 units. Now, I didn't state this question, but like, because we're calculating a bolus and to be consistent with what we've seen in the protocol before, we're going to calculate the number of milliliters to prepare for the bolus. Okay.
Okay.
So this is important. This is why we have the protocol, because in step 2 of the protocol, it tells me heparin 25,000 units and 250 milliliters, half normal saline. And then the bolus dose strength is 1,000 units per milliliter.
Mm-hmm.
So we're going to use the bolus dosage strength because we're calculating a bolus dose. Does that make sense?
Yes.
So when you do that, you will get 7.816 milliliters. And then what you would do is just round to the nearest tenth. So I would just round that to 7.8 milliliters.
Okay.
So that would be your bolus dose. Now, in clinical setting and reality, you may only be able to administer 8 milliliters or 10 milliliters, but in the math kind of bubble, we're just trying to calculate, based off of, pen and paper, paper and pencil, like math, pen and paper, whatever you're doing. So.
Okay.
Now, the next thing is we're going to calculate the increase in the infusion rate. So I want to know the new infusion rate in milliliters per hour. It told me to increase it by 4. Well, what was it originally? Well, originally was 18.
Okay.
So
So would that be 22?
You got it.
Okay.
So you would take the 97.7 kilograms, and then now instead of 18, or instead of 20, because that's what you've done previously, 22 units. That would be kilogram hours. So 97.7 times the 22, you're going to get 2,149.4, and that's units per hour. But we don't want units per hour, we want milliliters per hour. And because we're not using the bolus dose, we're going to use what it says in step 2, the 25,000 units in 215 milliliters, half normal saline. So that's what is available and what they're already hooked up to. That's their IV bag they're already connected to. 250 milliliters, 25,000 units. And when you do that, you're going to get 21.494, and that's going to be milliliters per hour. And we're just going to go ahead and round that to 21.5 milliliters per hour.
Okay.
Now, again, in reality, you may only be able to program the infusion pump to 20 or 25 milliliters per hour. So, and I don't even know if you guys have even done clinicals where you've done like a heparin protocol on patients or not. So,
no. Okay. Okay. All right. That makes sense. Thank you.
yeah, you're welcome. Any other questions?
No.